In this video, I'll look at shadow types in 3ds Max and some of the settings involved. I'll start out then looking at ray trace shadows. I can see here in this view I've got the target of my sun showing in the bottom right. One of the things we can do with the target light is to select the target, even if we can't see the light, and right-click and choose Select Light from the quad menu. This is using ray trace shadows, and what that means is that those shadows are perfectly even and crisp. Here's the difference. Real shadows spread over distance. The farther the light gets from the shadow generating source, the more spread out that shadow gets because, well, light bounces on the air. So for this light, using a ray trace shadow means all the geometry in here will shadow very, very crisply. What I'll do, for example, just to show this, is bump up the multiplier, maybe to 5 for my sun, and run a quick render so we can really see those shadows in action. What we can see here in the ray trace shadow, especially on the louvers on the second building, and right here underneath this dark shadows from building 1, is that the shadows in here are perfectly crisp. They simply go on being crisp out to infinity. Because it's a directional light, that light will remain parallel and give me that very stylized sun. I have shadows we can see also on the bus stop in the lower left. And these, coming from that emission area of the light, spread out. We can see where they start crisp and then get bigger and fuzzier because that light is emitting from an area and spreading. The contrast is kind of nice. I get blooms of light, long shadows from my street lights, shadows across buildings to add depth, and then spread shadows from my fixtures. I'll pull this back down as that multiplier is a little high. Here's 1.5, back down in that low sun range. The other types of shadows we have available then, aside from ray traced, are shadow maps. We can see here, as I pick one of the building 3 uplights, that under shadows are different types available. We've looked at ray traced, where shadows start crisp and stay crisp. Shadow maps then are a fairly old way actually of dealing with lights. They approximate the fuzziness of natural shadows, but are cheaper to render, and really date back to when computers didn't have very good power for ray tracing. Nowadays we can throw power at ray tracing at a lot of things and get it done with accurate shadows. What a shadow map does then, turning on shadows here for example on my uplights, is approximate the spread of that shadow by drawing a shadow map, which is available in the shadow map parameters. This is an image that is drawn into the RAM at, in this case, 512 by 512 pixels square before render time. Now when I press render on this, we're going to see a different image, and I'll render out a region to speed things up. In the rendered frame window, I'll click on the Edit Region button, pull this region down onto that middle building, and hit render. I can see one of my shadow map shadows cleanly here on the side of this building. It's got a nice fuzz to it on the top and bottom edges, as if that shadow had hit this surface and diffused out. It's not bad looking. I can see where this light does overlap a little bit, and this is the inherent problem with shadow maps. Because they're approximating the fuzziness of natural shadows, we need to increase the shadow map's size to get a better resolution and more accuracy. But that in turn is a hit in RAM and time. So it's a trade-off. Why then do we have them? Because a lot of things we do need general fuzzy shadows, not accurate ones. I'll compare this with a ray trace shadow, for example, hitting Escape, scrolling back up in the light, and rendering with ray tracing. With those lights using ray tracing, I have a dramatic difference. Dark black shadows on the building from the building parts the lights are hitting, cleanly intersecting the geometry and marching up the surface. That bloom at the bottom of the shadows is gone, and I can really see a difference in there. I may want to vary this around, or choose these lights to simply not have shadows, just to get that difference across in the shadow quality, and let the light simply play on the surface instead. When I turn off shadows on these uplights, for example, and hit render one more time, I think the building looks a little better. This is an important lesson in lighting. There's another option in shadows here, and that's to not use them. In this case, I like how this light is simply passing over the surfaces and not giving me large black areas here, but instead smoothly lighting and showing off this geometry. Now I'll zoom in on the bus stop. This is a photometric light here, and I'll select this bus stop and choose Group Open to be able to get to it. I'll pick my light, and what we can see here, if we scroll up to the top, is that this light is using ray trace shadows. However, because it's a photometric light, and we can see its emission area up here, remembering that it's a uniform diffuse aiming down, emitting from a long area, that these ray trace shadows are spreading out. That once we're emitting from a size greater than a point, a ray traced shadow here, and that's governed again by the shape area shadows rollout in the photometric lights, a ray trace shadow here will spread. Now you will take a hit in render time, as spread ray traced shadows take time to calculate, but we get some really nice effects. I'll pan out, zoom a little bit, and do a quick region render around the bus stop a little closer to show it. I'll use my zoom tool down in the bottom right and move in down to more of a street level. Once more, I'll pull up that rendered frame window, hit the Edit Region button, and put the region in the right place. I saw those shadows spreading out pretty nicely, so I'm going to make sure that region reaches to the side a bit, and when I'm ready, hit Render. What we're seeing here, and I have an 8-core computer going at the moment, is that I am taking a hit in time to render this, although it's really not bad. However, I'm getting, well, the best of both worlds. Light bulbs, and all lights actually, come from a source larger than a point. If we emit from a source larger than a point with a ray trace shadow, we get a spread shadow, giving me, more importantly, a small island of light inside this tram stop, bounded by shadows around that bleed off into other lights. So it's really an artistic choice, and a trade-off here in power and speed versus shadow quality. Shadow maps as an approximation may look decent and be a lot cheaper to render. Ray tracing may look spectacular, but when you're rendering several hundred or several thousand frames of an animation, there's a limit to how much ray tracing you can do, because you do have to get it done on time. I'll run one last comparison here. One of the things I'll do often is take this region once I've run it, pull it halfway over, and then scroll up, hitting Escape, and change that shadow type from ray trace to shadow map. Note that in Mental Ray, where we're seeing area shadows here, Mental Ray does not support area shadows, as area shadows are governed by ray trace shadows on lights that have areas. There's a Mental Ray shadow map, which is a variation on the original shadow map type, and Advanced Ray Trace, with a few more parameters available. I'll try just the basic shadow map for comparison on this and see what we get. On the left side here of the bus stop, we'll see our shadow map, and on the right is our ray tracing, and there's a very obvious difference. Shadow maps, then, approximate natural shadows. This shadow is not starting in the right place, and so although it's trying to be fuzzy, it's not casting correctly, and it's starting, well, out here, giving me an odd lit area outside of that bus stop. So this is where I'm going to make the artistic choice to run ray traced here and get an accurate shadow around this focal detail that needs to ground on the sidewalk. There's that final render, and once again my bus stop is sitting down on the ground.